Welcome again. This time we're in session 4. We're moving away a little bit from the earlier topic, and this time it is about evolution and the theory of evolution. There's a difference between those two, and that's what we're going to look at. What really is the theory of evolution, and if we looked at it carefully, would it stand scrutiny and examination? What we are going to do once again is to ask and place the whole argument and the whole discussion on premises, the first principles on why we are doing this at all. So here are the 4 that we will look at. Number 1, the reason to study and examine evolution. Number 2, the meaning of the word evolution. Number 3, biological classification as we know it. And number 4, the concepts of evolution. Let's look at each of those. The reasons to study evolution. Why should we look at it when everybody in the scientific world says it's right and okay and it is the thing that is happening all over the world? Well, some people still question as to whether those basics of the claim will stand scrutiny. So here's the context in which we're going to look at this. If the theory of evolution has a reasonable scientific base, then the study of nature and nature's principles could show that God is not needed, because the theory of evolution says that it happened by itself. Natural selection got into play and formed all the spectrum of biological organisms that we have today. So if that is true, we don't need any other agency to really bring us to this point in our human history. Number 2, if it is not reasonable, not scientific, then those events did not probably happen. And if that's the case, then the nature and its study could endorse the claim that we do need a supernatural agency, we call him God, to actually do the stuff that we see around us and to bring us to this point in human history. So that is the context in which we are going to look at the theory of evolution. Number 2, the meaning of evolution. Most people, when they use the word evolution, they think everybody else means the same thing. Not really. The word itself, evolution, means gradual changes resulting in improvement over a period of time. So it's gradual changes becoming better and better. That's all it is. Whereas the theory of evolution is a specific type of evolution described by Charles Darwin. He said that the starting point was one simple organism, and then it multiplied and made some changes, and those changes became so different from the original one that was supposed to be classified as another species or another genus. And then it went on from species to genus to the whole spectrum of biological classification we have on Earth today. So those two, they seem similar, but they really are not. Evolution, meaning change for the better over a period of time, is acceptable. In fact, it's observational data that allows us to say that. Yes, evolution does happen. The question now is the theory of evolution that clear? So we go to the spectrum of classification. The spectrum of classification of biological organisms, living beings on Earth. Number 1, the species. Those gradually change to form variations and subspecies and races and breeds. And the theory says, the theory of evolution says, then those changes became so great that you had to classify the later organisms as different from the previous organisms. So it became from species, genus. And then they multiplied, and a group of genera became so different from the original that it had to have another classification. So first species, then genus, family, order, class, phylum, kingdom, and domain. Domain is really not what we see. It has to do with the nuclei of the cells. If a cell had a nucleus, well, it was classified as this domain, and if it did not have a nucleus, it was classified as that domain. For our purposes, kingdom is good enough. But if you notice, I have highlighted the word phylum because we're going to look at it later on. Look at where phylum is in the classification, way up there, very close to kingdom. So when you look at the spectrum of classification, it is quite broad and big. So when we talk of organisms being classified, this is what we mean. And the theory of evolution says, starting with one organism, they branched out and became different until we have all these organisms that can be classified in this manner. Similarly, when we look at the word evolution, it means so many things to different people. Some of them use it for a certain part of evolution, and some of them use it for, say, the beginning of the whole universe, and some of them use it only to deal with how one organism became another species. Let's clarify that a little bit. So let's look at the concepts of evolution, because people use this word in quite a few different ways. So here are the concepts. Number one, cosmic evolution. That would refer to how the universe came about and evolved. It is not Darwinian evolution. We'll come to that in a moment. Number two, stellar evolution. How did galaxies and stars form? In the beginning, it was just radiation, and those radiation got gases and some early elements. But how did stars and galaxies form? That is stellar evolution. Then comes chemical evolution. How did these chemicals join together and synthesize themselves into what we know today as all these stuff around us? Chemical stuff. Gold, granite, silica. How did those occur? That would be called chemical evolution. Then the next thing that should have happened, these chemicals, say like rocks, granite, sandstone maybe, became a very specific structure called cell, cellular structure. So the inorganic matter became organic. So now it is organic evolution. How did cells come about? How did those structures evolve into what we know today as cells? That would be organic evolution. After organic evolution, after the cellular structure came about, is what I would call zoontic. Zo means life. So how did that structure, which earlier had no life at all, come about to now become a living organism? That is zoontic evolution. Then comes Darwinian evolution, in which this one organism or creature multiplied and kept multiplying, kept differentiating until we have the whole spectrum of the biological classification we have today. The one that is at the bottom there on the list is called microevolution. Microevolution is small amounts of evolution in which a species does become a variation or a subspecies or a breed or a race. Microevolution has been scientifically established. Nobody disputes that. In other words, evolution as a change, yes, acceptable. The question is, did Darwinian evolution really take place? And if it did, do we have good evidence that it is what it's claimed to be? Is it really that kind of clear-cut process that happened? Now we come to the fundamentals, having set this as a premise. The fundamentals of evolution require certain factors to be present and to involve themselves in the play of what happened. So here are 3 and then we will do another 3. So the theory of evolution requires at least these 3. Number 1, chance, probability. In other words, all the events are claimed to be only chance events. There was no question of any intellectual, intelligent activity that put these things together, the process together. Number 2, time. We require time because Charles Darwin mentioned a Latin phrase which said, natura non facit saltum, meaning nature does not like leaps. It likes only small steps. So if it is small and the changes come over a period of time, it would require huge amounts of time. It's called deep time, running into hundreds of millions and even billions of years. The third factor that is required is the question of series. In other words, sequence. This and then this and then that. There is an order. If you go backward, then it will be going backwards in evolution. So it has to be a series in which a sequence is maintained. Let's look at each of these and see if we scrutinize and examine them, that they would stand up to scrutiny. Number 1, chance. We discussed that in the previous session. The question of chance and the question of probability. Chance events means it occurred arbitrarily. There is no pattern to it. There is no sequence, real sequence, and it occurs in an unpredictable manner. Rules do not apply over there. Hence, we do want that a number of chances are given so that this would occur. These many chances, this would occur. And we saw that it can be mathematically calculated. The calculation is called probability. Therefore, the claim of a chance event can be put into a scientific study, mathematical study. If the number of chances required is too big, then the event didn't occur by chance. Rather, it was an agent, intelligent agent or agency that actually performed that event. We saw that to establish a law, the chance is 10 to the power of 50. 10 to the power of 50 is a big number. So if a chance event requires more chances than that, then most probably it didn't occur by chance. We saw how big that number was. Let's state it once again, give it a little context. If 10 billion humans performed a test at 1 per second, then from the beginning of the universe up to now, we would have performed about 10 to the power of 28 chances, that's all. So 10 to the power of 50 is a huge, huge number. What is the total chance afforded by the whole universe from the time it was, from the time it began? The number of seconds multiplied by the number of particles in the universe, multiplied by the number of interactions that could have occurred per second. Mathematicians have come up with a probable number. The total chance afforded by the universe is 10 to the power of 122. Wow, that's a big number. But remember, we saw Michael Denton saying that just 100 proteins coming together would require 10 to the power of 2,000 chances. And what about a whole cell coming together? 10 to the power of 100 billion. Way beyond what the universe can afford. So, the number of chances is simply too big to state that it occurred by chance. If it did not occur by chance, then life, which began and which is perpetuated today, had been done by an active agent, not by chance. Number 2, requirement of time. You know, in those days, people thought that the earth was young, the universe was young. Then, this is what George Levine, in the introduction to Charles Darwin's Origin of Species, says. It was Charles Lyell, in Principles of Geology, who supplied Darwin with the essential notion of geological time stretching for millions of years, during which the gradual transformation of species into varieties, into subspecies, into new species could unfold. But these postulated times, they say, is billion, hundreds of millions of years, billions of years, actually is not enough to do what they say it did. The debate is not whether the universe is young or old, but it's whether the old universe, which has 13.72 billion years of age, provides sufficient time for the theory of evolution. Look at one calculation. G.G. Simpson is a renowned evolutionist. Thus, as G.G. Simpson's calculations of rates of evolution show, the bat's wing, if evolved by normal Mendelian mutation and selective pressure, would have had to begin developing well before the origin of the earth. Just one part of one animal required more than the whole age of the earth, 4.5 billion years. Number two, the origin of species by Charles Darwin has only one diagram in which there are lines drawn across the page, meaning that each line represented about 1 million to 1 billion generations. Now, he had 10 lines, so after the 10 it became a variety. If the age of the elephant or the generation of an elephant is 30 years, and each of those lines is 1 billion, then we would need 30 billion years to change an elephant just to one of its variety. Not enough time. Number three, astronomers have told us that galaxies 12 billion light years away have been detected, and that is 1,368 trillion kilometers. Now, how did it get that far? We know the galaxies are moving. Our own galaxy is moving at the rate of 19 billion kilometers per year. Even at 10 times that speed, that galaxy would have required 7,000 billion years to get there. How does that compare to just the 13.72 billion years of the universe that we have today? Then the correct sequence. First the species, then the variety. Species is the parent, then variety. But look at what Charles Darwin's own words are. He was struck how entirely vague and arbitrary is the distinction between species and variety. The species, or the parent, was at times whichever was first discovered, or whichever was more common, whichever was greater in number, or whichever was wider in distribution. That is not a sequence. That's another factor put in. So if that's the case, then it's possible that the parent was not really the parent, was the daughter, or the daughter was really the parent. If that's the case, well, the theory of evolution could have been going in the reverse. Now, three more fundamental factors. The claim is that similarity shows a relationship between father and son, mother and daughter. Number two, it is structural changes that are required so that we can survive better, or the organisms could survive better. Number three of this second set, which would be number 6, Darwin's natural selection. In other words, something had to be selected. So let's look at these three. Does similarity actually denote genealogy, meaning birth giving rise to the next generation? Relative, blood relative? We have no written pedigree, said Charles Darwin. We have to make out community of descent by resemblances of any kind. In other words, none of the fossils that are buried there are buried with birth certificates. So how do we know which one is related to which? Well, we look at similarities, said Charles Darwin. Now, the scientific data does show something. It shows that an organism which has a genetic code specific, let's say organism A has a genetic code AA, which gives rise to its features, we'll call it A1. Organism B has a genetic code BB, which gives rise to its features called B1. We do know that the genetic codes, if they are close together, will give rise to features that are close together. That is accepted. Everyone recognizes that. And so they say that shows that, well, they did change. But no. AA producing A1 is one set, we agree. BB producing B1 features, agreed. But that doesn't mean A became B. For A to become B, we require a smooth series of intermediates which shows that A became a little different and then became B. That has never been shown. So here's what Herbert Nilsson from Europe, a big scientist, a scientist who was well known there, he says, we have also proved that a morphological similarity between organisms cannot be used as proof of a phylogenetic or evolutionary relationship. In other words, just because they are similar does not mean one came out from the other. One was the daughter of this parent. How about Austin Clarke? Look at his words. There is not the slightest evidence that any one group of the major groups arose from any other. This idea that they did arise was based on the theory, hoping that the theory would be established. What if the theory is not established? By actual information and data that we get from the fossil records, which is called paleontology. What if we don't get it? The fact is, we still have not got the data. The fundamental principle that similarity denotes is based on genealogy, not yet substantiated. How about whether structural changes affect survival? Here are Charles Darwin's words. The slightest difference of structure or constitution may well turn the nicely balanced scale in the struggle for life and so be preserved. In other words, what he's saying is that when some organism changes a little bit, and if that little bit change is really beneficial, then that is held on and passed on from generation to generation. And then as those structures are passed on to the next generation, another good beneficial change comes in and is added on to that. And so it goes on adding until we get another organism that really is much better than the previous one. That is the meaning of structural changes helping survival. But the slightest differences that Charles Darwin said has never been described. Why? Because those slight changes may not have affected survival at all. Look at another statement that he has made. Habits have changed without a corresponding change in structure. So, if habits changed to help survival, we really don't need structural changes to help survival. Can you see that point? So, what we are looking at now is the claim that there are structural changes. But a small change in behavior itself could do the trick. For example, they say that the neck of the giraffe was stretched out longer and longer as it reached out higher and higher for the foliage that was higher and higher on the trees. Really? Can you see how a little change in behavior could have compensated for that? So here is a small giraffe with not that long a neck, and it's eating the leaves at this level, and then the leaves at this level were maybe they were eaten up. So it had to reach the upper level. It didn't have to have a longer neck. It just had to lift up its nose and its mouth and pick up leaves higher. And if the leaves even higher than that had to be eaten, then it would have gone on its hind legs and put its forelegs up onto the tree and reached up. There's no need, in other words, to change the length of the neck. The fact really is, we can look around and see long-necked giraffes, short-necked gorillas, and even other organisms with no discernible neck, like centipedes, living in the same environment. So obviously you don't have to have that long leg. Therefore, changes really in structure were not required. How about natural selection? Nature selects only for the benefit of the being she tends. Does this selection make the aggressor more likely to succeed, or the victim more likely to escape? Now we have to agree that nature is blind. It cannot see which is the aggressor and which is the victim. So it has to help both. So if it selects both of them, really can you call it selection? If it selects the whole of nature, that is not really selection of any kind. So the word natural selection really is in question. Did nature really select, or did something happen by which they were all given those attributes and they are still producing their behavioral patterns and their offspring because of the pattern that they were given to begin with? So here are the fundamental principles. Supposed to be in the theory: chance, not enough chance. Requirement of deep time, we don't have enough time. The correct sequence has not been set because the daughter could be the parent could be the daughter. Similarity denotes genealogy, that has not been established. Structural change really causing survival, that also has not been shown clearly. Natural selection, really selection going on? Not a single fundamental principle has been satisfactorily established. We'll go to the next one in the next session.
If you have enjoyed this presentation with Dr. Subodh Pandit and wish to watch more of this unique 13-part series for free online, visit the website godfactorfiction.com. That's godfactorfiction.com. If you would like to order this fascinating series on DVD, it is now available from Whitehorse Media. To order from within the U.S., call 1-800-782-4253. Dr. Subodh Pandit has written 2 eye-opening books entitled Come Search With Me, Does God Really Exist? And Come Search With Me, The Weight of Evidence, which further explore the topics of evolution, theism, atheism, and religion. To order these books from within the U.S., call 1-800-782-4253. If you live outside the U.S., you may also easily order them on Amazon.com.